We are live. Okay, I think we are live. Hello, everyone. I'm welcome all on Data Phoenix webinar. Today we will speak about amazing topic, how to better build in or on what way to better build LLM application. And today with us, Greg and Chris from amazing AI market space. They do amazing courses about AI, about LLMs, ML ops, and they today will share their knowledge and expertise about build LM application. So I give the microphone to Greg. Uh, he will continue and share all what he prepared with him team.
Thanks so much, Dimitri. I appreciate it. It's great to be here with Data Phoenix. And everybody, welcome to the show. I want to go ahead and just table set for a moment and let you know that what we're going to cover today in 60 minutes is a little bit ridiculous, and we know it. Okay, so buckle up, everybody. We're going to take you through a series of trailheads through the woods of RAG and fine-tuning. It does take us weeks to cover this in our formal course. Let's get into it. All right, so should I use RAG or fine-tuning? Answer is yes, you should. All right, we start here. We will end here. Just to give you a little bit of background heading into this. For 10 years as a university professor, I saw that the only people that were succeeding in a 21st century workforce were those who were building with the skills that they learned. They were not getting degrees and becoming successful. They were learning, building, and sharing. In the spirit of not just learning, but always building, today we're going to talk not just concepts, but code. We're going to actually make some stuff. So let's align exactly what we're aiming at today as we get into it. We want to get an intro to both RAG and fine-tuning patterns. We want to understand that RAG and fine-tuning are not alternatives. They're just two pieces to the puzzle. And we want to build a fully domain-adapted RAG application with Llama 3, with fine-tuned embeddings, and a fine-tuned LLM. We've got a slide deck for you today that we're happy to share. And we've got 3 notebooks to get through today in just 50 minutes. So you'll have plenty of time for questions at the end. If you have questions throughout, please drop them in the chat and we'll do our best to asynchronously answer them. Okay, let's talk patterns. Then we'll talk LangChain, build a quick RAG system, and do some fine-tuning to domain adapt it. When we prototype, we want to understand that we're generally going through a few steps. We're starting with prompt engineering, and then we're typically moving to RAG and then to fine-tuning. You might move to agents thereafter, but generally you're kind of starting with prompting. You're then optimizing what's in the context window before you optimize how the LLM should behave or act, before you're sort of optimizing all of the above. Now, you could even put agentic reasoning into your RAG system, into your prompts, into a lot of different places. That's beyond the scope of today. And it's just generally a meandering process to get to the point that you're going to actually have a human level performance application. So let's talk a little bit about RAG. First of all, to understand RAG, we need to understand why RAG, and it helps solve the problem of confident false responses that LLMs have. How does it solve that problem? Well, we fact check those responses through reference material. We retrieve references, we add those references to the prompt, and then we generate better answers. RAG can be broken down into 2 primary aspects: dense vector retrieval and in-context learning. When we talk about asking our question to a RAG system, we're talking about putting it through an embedding model, searching for stuff that's similar in a vector store, in embedding space, similar. We then set up a prompt template and we return the similar stuff that we found now in natural language to our prompt. This is the process of dense vector retrieval. By simply adding this context to the prompt, it allows us to do some additional learning. This is the idea of in-context learning. And this, my friends, is RAG. But we haven't actually done the G yet. We haven't actually done the generation, which occurs at the end through the chat model to get our better answer. When we talk about the retrieval aspect of RAG, and we talk about dense vector retrieval, I want you to think about embeddings in general, text into numbers. You can look at an embedding space like this. Where do you put the fruit? Well, you put it with the other fruits, right? Or you can look at an embedding space like this. Puppy is to dog as calf is to cow. On the X dimension, maybe you have age. On the Y dimension, maybe you have size. But where does Data Phoenix fit in on this? Where does AI Makerspace fit in on this chart? We need more dimensions. How many? Well, generally we're using quite a lot, perhaps many thousands of dimensions in state-of-the-art embedding models today. Classic embedding models, they look more like the word-to-vec model. Came out in 2013, very classically. And this was one of the original models that was proven to be successful on many downstream tasks, something that we hear a lot today in the space of LLMs. Embedding models today look more like the OpenAI ADA embeddings or the Text-3 embedding small model that just came out, or embeddings that you might find on the Massive Text Embedding Benchmark leaderboard. When we talk about retrieval, what we're talking about is we're talking about asking a question, searching the database for stuff that's similar, and then returning the stuff. It's this process that we saw. And when we think about the vector representation here, we're using vector format on our question to search for vector, generally cosine similarity within our vector database. And then we will return the stuff in natural language. Of course, we have to look in our vector store to find the similar stuff, which is created by taking our documents, chunking them, running them through the embedding model, and storing in the vector store. The retrieval process is done by wrapping what's called a retriever around the vector store. This allows us to ask the question and return the appropriate context. So that's dense vector retrieval. What about in-context learning? Well, we already kind of talked about it. And it's not fundamentally different than prompt engineering itself. In fact, when we talk about giving good instructions or giving the right context to the prompt, we could say some of that is talking about the retrieved context. Remember, we are simply optimizing context when we go from prompt engineering to RAG. In-context learning is an idea born out of the language models or few-shot learners paper, where we saw that for a large enough model, in this case 175 billion GPT-3, we could move from 0 shot to 1 shot, that is instruction only, to just one example and start crushing performance. That was pretty dope because we saw that scaling greatly improved few-shot performance. Now, when we think about retrieval, when we do it well, we're giving a really good example to the prompt. And we can sort of think about the fact that if we do retrieval better, we will get better generations. This happens through augmentation of the prompt, which is essentially prompt engineering. So all of these things come together as we consider the patterns of generative AI. And RAG as we improve our generations. This brings us to fine-tuning. And fine-tuning, the way to think about this is we can really root this in SFT, in the classic paradigm that we're so familiar with, because we need an input and an output pair of some sort to do fine-tuning. Now, there are many ways to dive into the details of how these models are trained, from unsupervised pre-training to SFT to some of the more finer tuning alignment techniques. There's a lot going on there. But what we want to really focus in on is that once we grab a helpful, meaning good at following instructions, model off the shelf, we can adapt it to a particular behavior or domain through fine-tuning. And we're doing this, remember, through the idea of kind of giving more examples. As we move from prompt engineering to fine-tuning, we're optimizing the LLM, how the model should act. We're training the model with more and more examples. This is called the task-specific spectrum. As we move from 0 shot to 1 shot to few shot, we can move all the way up to I have too many shots for the context window, and now I'm doing fine-tuning. Another way to think about this is that we're moving the context into the model. In other words, we're sort of piggybacking directly on this idea of in-context learning that fundamentally itself was born out of the ideas of fine-tuning. It's all about how the model should act. There are 3 primary forms of fine-tuning. 1 is we can train it for a particular task. 2 is we can constrain the input-output schema. And 3 is that we can actually train it to interpret language in sort of a different pattern than the language it was trained on. We can look at new words and connect them. For more on this and more on much of what we've discussed already, we've got other YouTube events online that we'd love to point you towards. I want to go ahead and bring Chris, the whiz Alexiak, up to the stage to discuss this kind of balance between RAG and fine-tuning. When I think about fine-tuning versus RAG, Wiz, when should I use one or another if I'm just trying to get like the best performance? What do you think?
That's a great question. I mean, it's obviously going to depend by a use case, so take that with a grain of salt. But the basic idea here, or the way that I would think about this, is if I want to add knowledge to my LLM, if I want to add, factoids or things like how a certain domain's information works, I might use RAG as a first pass. Versus if I want the model to behave differently, right? So perhaps work as a translator, or use something like instead of just knowing facts about the domain, speaking as if it is from the domain, right? So that's when I would want to use fine-tuning. And those are kind of like the two, very surface level, but I think good places to start from when you're considering this question.
Okay, so just to recap, if you wanted to sort of draw off of facts directly, then RAG. And if you want to really kind of dial in the way that it acts, that its behavior is versus just sort of a general LLM towards maybe a specific task, this is where you would look more at fine-tuning?
That's a great summarization. Absolutely, yes.
So, I mean, but isn't it the case, though? Isn't it true, Wiz, that sometimes RAG and fine-tuning can actually do the same exact thing when we start to get kind of aligned of like, yeah, I need facts, but I need them in a specific form. we might be able to accomplish the same thing sometimes with both of these tools?
Yes, I think that there is a small but real space in which they share some overlap. I would not say it's strong overlap all of the time, but there are certainly cases where they can be closer together than further apart.
Okay. So there is a Venn diagram, and there
Yes.
exists betwixt and between the two sides an overlap. Now, if I'm starting and I'm prototyping, is there always one that I should pick first? Can we make it simple in that dimension?
Yeah, and it's RAG.
Okay.
A lot of these models have decent enough performance on, what I would refer to as, that zero shot task capability, right? I think that's a fair way to describe it. And because of that, you can usually get pretty close just by using things like, if you really need to, fuse shot, prompting, and then use RAG as well. So you're kind of doing both, but in a much simpler way. At the end of the day, fine tuning is just going to be a more intensive process, no matter how you look at it than RAG. And so starting with RAG and using prompt engineering, I think, is the way I would recommend to approach most problems.
Love it. All right. Thanks, Wiz. We'll have you back in just a minute as we start building. If you have other questions, please drop them into the chat. If you've got specific questions about your RAG and fine tuning, we'll do our best to answer them. But for now, it's time to build. And we're going to do that with LangChain v0.1. The way that LangChain talks about LangChain today is that it's all about enabling LLM applications that leverage context and reasoning. In other words, RAG and agents. We're talking about RAG today. So let's zoom in on the specific aspects of LangChain that we need to look at. Can you guys see that? Yeah, me neither. Let's zoom in a little bit on the core pieces that are going to help us build a simple RAG system today. The first one is the chain in LangChain. What is it? Well, a chain is the primary abstraction, and it's just a sequence of calls to other components. We can build chains out of lots of different parts and pieces. Lego blocks is a great analogy here. And chains, of course, are kind of where LangChain began. So we're not really doing anything super complicated here by chaining things together. LangChain expression language, if you could sort of think of this, is sort of a way to easily compose chains. So if you think of the loops in a chain, these are sort of creating the loops. In LangChain, these loops are called runnables. And there's a lot of details associated with LangChain expression language that you can look into. And I highly encourage you to do that. But we can create these really elegant looking chains with just this simple bar syntax now. And that's very cool. And you'll see that in the code in just a moment. We're also going to use chat models. And specifically, we're going to use chat model style syntax. If you're familiar with the OpenAI API, you might be familiar with the system user assistant messaging. In LangChain, they've articulated this a little more specifically with the system human AI message templating. This chat style model syntax from OpenAI essentially takes in a list of messages and outputs a single chat message. And the roles here, system user and assistant, are worth noting. Specifically, the system is where you give those instructions. The user is either your user engaging or you acting as your user engaging. And then the assistant is where you're getting a response or you're acting like the AI giving a response. You could use this for a one-shot, two-shot, few-shot setup, providing your own examples in the prompt, for instance. Speaking of prompts, we want to set up a template. We saw what the template kind of looked like before in our diagram. And so we can kind of take this idea of our RAG system and we can imagine gluing this together with LangChains. And I want to take a look at just a couple components of this before we start building. Number one is the text splitter. And I'm just going to say a few words about a few key components. Notice we've got document loader, text splitter, vector store, embedding model, retriever, and model here. Let's just take a look. Text splitting. It's all about chunks. What gets chunked gets retrieved. How are we chunking? With the Swiss Army knife of chunking, the recursive character text splitter. This is the de facto industry standard. And when we think about the vector store and retriever, these are also core components that we want to focus in on, because a lot of these will have a big effect on our retrieved context. The vector store is real simple to build it. We load the docs, we split the text, we do the embeddings, we store the vectors. Yes, it's just a database full of vectors. And in fact, the only ingredient is chunks in that database. So it's pretty straightforward. We've already talked about the retriever being the wrapper. It's essentially a more general interface than a vector store. So our build today is going to be using open source models, the latest and greatest, of course, including Arctic Embed Medium from Snowflake and Meta's Llama 3 8 billion instruct model. We're going to do a fun kind of application today. If you guys have seen the Elon Musk OpenAI lawsuit, what we're going to do is we're going to build a quick RAG system to be able to ask questions against this bad boy to see what's going on with Elon and OpenAI. And for that, we go over to Chris the Wiz to show us how to get set up. Wiz, over to you.
Oh, yeah. Okay, so basically, we are going to go ahead and we're just going to get started. I mean, best way to start is by starting. So the thing that we're going to do today is pretty straightforward. The idea is that I'm just going to stretch the screen out a little bit. See, I got some room here. Perfect. Okay, so the basic idea is that we want to build a RAG system and we don't want to do anything but use the model. And so the way we're going to do that is by just making sure that we have our required libraries. In this case, we're going to be using LangChain. You'll notice that we're also going to be using LangChain Community, and we're also going to be using sentence transformers. This is going to be important later when we talk about our embedding model. So we'll also use a few other libraries to help us run our model, and then we're going to grab some data. So the data that we're going to use today is the Elon Musk complaint data, as Greg just talked about. And the idea is, it's a bunch of just legal jargon in a single file. It's absolutely just a dense legal information, right? So not parsable by non-law folks, except for some of the summaries. Now, what we'll want to do once we have that loaded, using our PyMu PDF loader from LangChain's community integrations, is we'll want to chunk that. So we'll want to split it up into bite-sized pieces, essentially. And the reason we're doing this is because we don't want to send the whole document into the LLM every time. That's going to be expensive. And we want to be able to, find related documents across the document that aren't just like close to the first thing that we see. And this is going to help us to make sure that we're able to do that. So we're going to use this recursive character text splitter as our chunking strategy. And you'll see we go from one PDF, which is this complaint, to 189 total documents, which is pretty cool. Then we're going to build our embeddings and dense vector search part of our pipeline. The main piece of this pipeline is straightforward enough, which is just loading our Hugging Face embeddings pipeline. This relies on sentence transformers, which is why we loaded it as a dependency. You can see that we're just going to use the base Snowflake Arctic Embed Medium. So this is a small embedding model, but it performs very well, punches way above its weight class. And you can see here that we're going to go ahead and make sure that we're doing this on GPU. So this is with CUDA, meaning that we're going to accelerate this sentence transformer with our GPU. So our embedding is fast. Then we're going to grab our face backend. Face is going to be the thing that we use to quote unquote power this. Now, when I'm saying powering, what I mean is that we're going to use a vector store from LangChain and we're going to power it or use the algorithms that are implemented through Meta's face in order to provide the things like, our retrieval piece, so our lookups. So the way that we do that is that we create a face vector store from documents. We're going to pass in those 189 split chunks, as well as our GPU accelerated embedding model, and then we're going to store all of the resultant vectors into our vector store. Nice. Because we're LangChain, we're going to want to make sure that we're using their .asRetriever method so that we can use this vector store as a retriever. Now, we are going to use Llama 3 to power our the G part of our RAG, so that's the generation. And because of that, we will need to make sure that we log into our Hugging Face account, which means providing our token. You can provide a read token for this notebook, but you do need to make sure that you provide a token and that you're using either a different version of this model, or you have already got permission from Meta to use this model. So keep that in mind. We do need to make sure we're doing that, and we're going to grab the tokenizer as well. Then we're going to load our model in 4-bit. Like Greg said, there's we've done a lot of different material on this, so you can check those events out if you want a bit of a deeper dive into either of these techniques. In this case, loading in 4-bit, we're basically just loading the model in a way that doesn't blow up our GPU memory, which is very convenient. Then we're going to create a Hugging Face pipeline out of this. We want to just basically ensure that this return text equals false is set, or return full text is set to false. If we neglect to do this step, we might wind up with some wonky generation, so we want to make sure that we have it set to false here. Then we're going to shove our Hugging Face pipeline from transformers into a Hugging Face pipeline LangChain integration. So we just put in our pipe there, and then we pass in our max new tokens to make sure we're not generating too much. We do want to make sure that this is able to, basically generate quickly. And then we're going to go ahead and create our RAG prompt template. Now you'll notice that I have all of these weird kind of tokens all over the place, and this is just the format that Llama 3 instruct expects. So we have our beginning of text token. This is like our beginning of sequence token. And we have our end of text token. We also have our header tokens. So this header is basically like our roles as we know them from OpenAI, right? So this is our system, and then we have a we have a user, and then we also have an assistant. Now the model is going to generate the assistant completion for now, but that's fine. And then we'll go ahead and we'll set this up into a chain. Now, I'm not going to dive too deep into the chain. Again, we've done a few events on it, but the idea is that we want to grab context and questions. So we ask a question. We already have it. We don't have context. We need to retrieve it. So we pass our question to our retriever. We do this step in order to pass that context through in a way that makes sense to the next step. And then we pass our context as well as our question into our RAG prompt, which is formatted, sent to the LLM, and then parsed as a string. Easy peasy. Then we're going to go ahead and just test it. So we get a response to the question, what issues does Elon have with OpenAI? And we can see, according to the provided context, Elon Musk has issues with OpenAI Incorporated because his contributions have been blah, 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 blah. It's kind of dense language, but it's doing a good enough job. And where does this complaint take place? We get the classic, I have no idea. So it seems to be doing the right thing here, which is great. And that's how we set up our kind of initial RAG pipeline with no other, additions or changes, just using raw embedding model. And so we'll go back to Greg to see what we're going to do next.
All right. Yeah, that was rocking. Good little RAG system saying, I don't know, it's not fact checkable. So how can we dial this in even more? Well, this is where we talk about domain adaptation of our RAG system. And this is where fine-tuning comes in. When we talk about fine-tuning embeddings, this might actually be the first type of fine-tuning that you use if you've just done some RAG. This is going to be useful in general if you fine-tune on the data that you're doing RAG with, as we will today. But it will also be useful if you're in any sort of specialized domain. For instance, with lots of jargon, like lawyers or doctors or wealth advisors, government acronym soup, researchers at university or in large bureaucracies, there are just tons of specific language to that domain or location that people need to know. And so, it's not unreasonable, if we recall back to this retrieval really driving the quality of generations, to want to do the embedding model first before we get to fine-tuning the chat model. Now, there are lots of ways to go from simple to advanced RAG. We're going to focus on first embedding model fine-tuning and then LLM fine-tuning today. But optimizing your chunk size, using metadata, that's where sort of agents and reasoning can really come into play, is when you start to do metadata filtering. Or re-ranking is a very easy thing to pull out and just try. Lots of different retrieval algorithms, lots of great ones built into LangChain. We'll share some resources at the end to show you how to do some more of this stuff. But for now, let's think about fine-tuning those embeddings. What do we need to do? Well, we need input-output pairs, and they will be question context pairs directly taken from that Elon OpenAI legal document. And we will be then optimizing and tuning our model so that we're trying to improve the loss function. So this is sort of the big idea in general when we do fine tuning or when we do training, is we're optimizing loss functions. No different here. The loss function is just a little bit different, the loss function itself. But we're going to do a loss function tuning for fine tuning embeddings, loss function tuning for fine tuning the LLM. On embeddings, remember the data is going to be the question context pairs. And that's what it takes to fine tune that embedding model. And with that, we're going to go to Wiz to show us how to fine tune the embedding model before we get to fine tuning the LLM.
Oh, yeah. Okay, so this one is pretty straightforward, and it's made a little bit easier with some friends. So what we're going to do is first just get some boilerplate. The idea here is that because we're going to be using Llama Index, that's the friends that we're going to be leveraging today. The idea is we want to be able to say, you can run an async loop in Colab. We just have to do this step here, so that makes it easier. Next, we're going to go ahead and just fine-tune or grab the dependencies from Llama Index for embedding fine-tuning. Then we're going to go ahead and we're going to grab some remaining dependencies to make sure that we can run our sentence transformers-based embedding model through Llama Index. So we are going to be using OpenAI to generate synthetic data that we're going to use to train our embeddings model. And so we are going to need an OpenAI key here. Then we're going to grab the same data we did before, which is Elon Musk complaint data. We're going to go ahead and load it. We can see that we have 54 nodes worth of data. Remember, in Llama Index, node equal document from the rest of the different NLP domains. Then we're going to grab their generate QA embedding pairs, which is going to surprisingly generate QA embedding pairs. We're also going to grab our embedding QA fine-tune data set. The embedding QA fine-tune data set is basically just a way that we can set this up and make sure that we've got it in a data set that we can leverage later. We're going to use GPT-3.5 Turbo. Because we're using the answers, right, or our context or the node as an answer to the question, we only actually need to come up with a question. So we can use GPT-3.5 Turbo to do that, no probs. You're going to see that this is going to be all 54 nodes, and it's going to take about, 2 minutes. Then we're going to grab our actual model. We're going to load it in to the fine-tune engine from Llama Index's fine-tuning integration, and basically just pass in the medium model, and then we're going to use Snowflake fine-tune as our output directory. We're only going to do it for 2 epochs. It's a very short document comparatively, and then we will go ahead and we will fine-tune it. Fine-tuning takes very little time at all, even in the T4 that I used to do this. And then we can go ahead and we're going to get the fine-tuned model out. of our fine-tuning engine. We're going to set up a sentence transformer that points to that output directory. We're going to provide a write token to Hugging Face this time, and then we're going to push that fine-tuned model to the hub. So this is all we need to do, right? Very few steps to do this, thanks to the friends at Llama Index, right? So this piece here, where you get the fine-tuning engine, and then you just call .fine-tune, is abstracting away a lot of the hard work for us. As Greg said, it does use a very specific loss here. The idea is that in order to provide negative samples, we consider every QA pair that isn't the QA pair we're looking at is a negative sample, and that lets us do this contrastive training in order to get very good results. And remember, what we're trying to do here is we're trying to, if we just permit ourselves to imagine our embedding model as like a word cloud, we're trying to move words that are more related in this particular corpus closer together, and words that are not related in this particular corpus further apart. And that's the idea of why we're fine-tuning this embedding model. The idea is that if we're able to do that very well, then when we do things like look up relevant documents, we're going to be more likely to look up the most relevant documents to our corpus. And so this is a technique that's been shown to improve the performance of RAG pipelines very well, and it is very straightforward and cost effective to implement. So with that, I'm going to pass you guys back to Dr. Greg, who's going to take us to the next step.
Yeah, and I love this idea of sort of rewiring the embedding space of words to align more with the way a lawyer would use them. Very cool. Now, speaking of lawyers, one of the things that we can do now with our domain adapted RAG system is we could potentially make it a little bit easier by fine-tuning our chat model to understand the output, the ultimate generated answer. How might we do that? And what problem might we focus on solving to get there? Well, when we fine-tune LLMs, remember what we're doing is we're generally taking one of three primary forms: to a specific task, constraining the input-output schema, or language training. Since we're using legal language here, let's do some language training. Have you ever read something like this? By way of example, and not as a limitation, you agree that when using the services and content, you will not defame, abuse, harass, harm, stalk, threaten, or otherwise violate the legal rights, including the rights of privacy and publicity of others, blah, blah, blah. And just been like, what? Well, no worries. We can simplify this kind of language to something like, don't be a jerk, don't hack or cheat. We don't have to ban you, but we can. We'll also hit up the police. Often, too often perhaps, lawyers are hard to understand, but we can do the same things that they're saying with simple language, like you're just talking to a person. And there's a great data set for this that we'll use for fine-tuning today called the Plain English Summarization of Contracts data set. And the way to think about this is we're going to fine-tune the language here at the end on our chat model to make this happen. And that will complete our fully domain-adapted RAG application. And for that, we go back to the Wiz to see just how different this fine-tuning is from our embedding model.
Yes, thank you, Dr. Greg. Okay, this is the the next step. So we've got our basic RAG pipeline, great. We've got our embedding model fine-tuned, so it should perform better on our corpus, great. Now we're going to actually fine-tune the model to give it a new behavior that we can leverage in our RAG pipeline to make it easier to interact with. So first thing we're going to do, grab a bunch of dependencies. We're going to do some training, so we're going to get transformers, path, TRL, acceler, bits, but the classics. from Hugging Face's suite of tools. We're also going to be using that data set that Greg mentioned, which is a very interesting data set. You can see that there's a just a link to the GitHub here, and it's just a bunch of JSON that has a EULA or terms of service, and then a summary in natural language of it. And the summary in natural language is very short and informal. As you can see, welcome to Pokemon Go, blah, 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 blah. And the summary is just, hi, right? So, okay, dope. We're going to load that up. We're going to convert that into a usable format. In this case, we're going to convert it into a JSON-L array, and then we're going to convert that into a Hugging Face data set, which is pretty cool. And then we're going to look at the examples, right? So just like we had before, big TOC thing, and then just hi. Okay, so it's definitely summarizing, right? Now again, and we go a little bit more into a little bit more detail in the notebook about this, or in this notebook about this, because we're going to fine tune with it. We have this idea that there's like a specific way that we should prompt this, and we have to care about these headers, so our system, user, and assistant headers. And the idea is that when we're training, we actually want to show the model sequences that include the intended generation, right? And this is how it's going to learn how to generate the right thing. We're also going to set that up into a format, and we're going to split it apart so that we can use the same format, or so we can use this for generation and for training and inference, just so we don't have to do, two separate full prompts. We're just going to be smart about how we set it up. Then we're going to create a create instruction helper function, which by default is going to include the response, so we can use it with the TRL library, but we have the option to dig in there and change it over, which is pretty cool. So that's going to convert that original thing that we saw, which is the welcome to Pokemon Go video, blah, 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 into this instruction templated version of that, which includes the intended generation or the summary. Okay, awesome. So let's go ahead and, prepare our data set by adding a small test set. You can see we don't have a ton of rows here, so, it's definitely a toy example, but it makes a good point at the end. And the idea is we have the 76 rows versus 9 rows that we're holding out for test, just so we can see how it does. Then we're going to load our model. Again, because we're using Llama 3, we need to make sure we're logged into the Hugging Face Hub, which we do by providing a token. In this case, we are going to want to provide a write token because we are going to push our resulting model to the hub. We're going to load this thing up in 4-bit quantization, just like the other notebook. And we're going to do a little bit of work on our tokenizer to make sure it works well with training. You can notice we set the padding side to right, and then we're doing this pad token trick here where we're setting the pad token to the end of sequence token. Typically, I would not encourage doing this method, but because we're packing the data set, we can get away with it, and it works very well. If you weren't, you would want to have some other padding token, like maybe the unknown token or something that doesn't that isn't going to lead to weird generations at the end of the day. Then we're going to use LoRa. LoRa is a method of parameter efficient fine-tuning. All it does is instead of training all of those billions of parameters that the model has, right, 8 billion of them in fact, we're just going to train a subset of them based on this rank. The idea is instead of training all the parameters, we're training a small number of parameters, and that's it. Then we're going to do some fine-tuning, a classic, right? Just a big wall of hyperparameters as our training arguments. Everything's pretty standard here. Karpathy constant for learning rate, small batch sizes to keep the GPU memory down, and a small number of epochs because we have very few examples. So we're almost certainly going to overfit this model, but it's going to show the results well, so that's fine for this case. We're going to use the SFT trainer. We're going to pass in the training version of our prepared legal set. We're going to pass in that helper function we created earlier that makes the prompts, right, the formatted prompts. And then we're going to pass in our PEF config. We're going to artificially limit our max sequence length to 2048 here. The only reason we're doing that is to, again, keep GPU mem down. And then we're going to go ahead and use that packing equals true that I referred to. What this is doing is instead of using one example in one context window, right? And you saw the examples we had, like the TOCs are long, but they're not like 2,000 tokens long, right? Especially when the summaries are very short. So, say one summary or one example and summary pair takes, 500 tokens even. If we only put one in per iteration, we're going to have kind of like 1,500 tokens of padding every single iteration, right? Which is not helping us. It's not hurting us, but it's not really helping us at all. And so packing is going to let us shove 4 of those prompts into this space in order to effectively use that context window during training. Then we're going to use our dataset quargs. These are important. We're handling tokens manually, so we're telling the TRL library, you don't need to handle those. We've handled those. Then we're going to go ahead and call .train. Our model will train. We almost certainly overfit. That's fine. It's an okay thing to do in this case. We're going to save this model, free up our memory, and then load it back in with the PEFT for causal LM transformers implementation through PEFT. And then we're going to go ahead and load it into a pipeline, just like we did our Llama 3 model. And then we can test it and see that, basically, here's all this text, and our model generates only this text. And then the ground truth summary is this text. And these are not too far apart. They're not exactly the same. And I think that the actual summary is a little bit better, but it's definitely a summary, and it's definitely closer than this whole block of text, which is great. If we try another version, we can see exactly the same thing, right? We're definitely getting there on these informal natural language summaries. Now, we're going to create our final RAG pipeline. The way we're going to do this is we're going to include, this is exactly the same thing we did in the first notebook, load the data, split the data, create our embedding model, except this time, we're not going to use the base version, we're going to use our fine-tuned version, right? That's why we did that fine-tuning. So we're going to plug that in there. Then we're also going to create our face-backed vector store. Then we're going to convert that to a retriever. We're going to set up our RAG pipeline. First, we need to set up our actual model again. So remember that the Llama instruct tune version of Llama that we have trained in this notebook is not going to be used for our actual RAG pipeline. We're going to use a separate version of the Llama 3 model for that, which is just the base version. And then we're going to load that again in 4-bit, of course, create a new pipeline for it, shove that into the Hugging Face pipeline, integration from LangChain, create our RAG prompt, create our summarization prompt, and then we're going to make this little summary function, which is just going to pass in a string and then return a string, and that string is just going to be summarized. Then when we build our RAG chain, it's going to be exactly the same as it was before, except this retriever is now powered by our fine-tuned embeddings model. And then instead of just, getting the output from Llama 3, we're going to go ahead and we're going to summarize the output of Llama 3 and then pass that back. So the idea here is that we're going to summarize every query. Now we could do this different ways if we wanted to only summarize some of them, all kinds of things like that. But for this example, we're just going to showcase it summarizing everything. And the idea is when we ask that same question, what issues does LN have with OpenAI? We get a shorter, more natural language version of the response, and it's more relevant to our question, which is pretty cool, right? Originally, it was talking about kind of the broader issues LN has with them using his copy, whereas now it's talking about, the actual main crux of the complaint, which is this idea that, it's out of control. We're also going to ask a question like, who is and what is fiduciary duty? And then the response is Elon Musk is owed a duty by the defendants under California law. The actual definition of fiduciary duty is very verbose and hard to parse. And so this is a nice little summarization of it, which is what we were going for. And with that, I will pass you back to Dr. Greg as we conclude our final, total compilation of fine-tuning plus RAG.
Woo! Woo! Full domain adapted RAG. A lot going on there. We told you guys it would be a whirlwind today. We saw RAG is all about adding that external knowledge, those factoids, dense vector retrieval, and in context learning. Make this up. Fine tuning, we can think of it as SFT. As we move from prompting to fine tuning, we're on that task specific spectrum. 3 types, including task training, constraining the IO schema, and language training. We can fine tune embeddings with question context pairs or LLMs with question answer pairs. And generally, we want to move from prompting to RAG to fine tuning embeddings to fine tuning the LLM. So should you use RAG or fine tuning? Yes. You should use both as you go from prompt engineering to optimizing the context, to optimizing the LLM, to trying to get something that optimizes both, maybe even adding some agents and ultimately achieving human level performance. If you want to go deeper, we've got lots of resources on things like advanced RAG, on things like LangChain and Llama Index and doing agents in both, on practical fine tuning, on parameter efficient fine tuning, quantization, and LoRa, and even on alignment with techniques like RLHF and DPO. We even just did a production deployment event. We're on YouTube Live every Wednesday. This was from yesterday, where we focused in on the API endpoints capability in Hugging Face, in case you wanted to, let's say, put a user interface on this application and deploy truly scalable embedding model and LLM endpoints for your fine-tuned models. You could use this information to do that. Keep learning for free with us. Every Wednesday, we are on YouTube Live. You can find all of our events on Luma. And we also offer a full course on LLM ops absolutely for free on GitHub. We'll be releasing an LLM engineering course that we taught last year as well, soon in the months to come. Please do join us on Discord. If you dug this today, know that we don't always go this fast. In fact, we try to avoid it at all costs. But follow us on YouTube, like and sub, and then also on Discord. There's always folks building, shipping, and sharing. If you're ready to accelerate your career, we do have an 8-week boot camp. It starts up on May 28th on AI engineering. Everything you need to go from LLM applications, prototype to production, from all of your firsts, first LLM, first RAG, first fine-tuning, first agent, all the way to fully domain adapted production deployments at demo day. We're getting lots of great outcomes from students that start with very little experience and end with much more. Please connect with Dr. Greg and the Wiz on LinkedIn. And questions time. Wiz, let's try to tackle some of these bad boys. Woo, that was a lot. Let's go. Jumping right in. Can you speak to the benefits of semantic chunking, Wiz?
Yeah, I think so. Semantic chunking is dope. It's just a, so think of it this way. So right now, when we chunk, we're making an assumption, and the assumption is that if we split by, if we're talking about specifically recursive character text splitter, right? We're talking about chunking by paragraph, then by sentence. So why do we do that, right? Well, the idea is that information that's kind of cordoned off in that way in the text should be related to each other, right? Like paragraphs should be about kind of the same idea. Sentences should definitely not contain many different ideas, right? And so the idea of semantic chunking is, well, why not just like literally parse the documents based on their potential semantic meaning? And that's the idea of semantic chunking. The benefits are that you are way more likely to retain chunks of information that are related to each other, which means that when you pull a single chunk, it should contain a single cohesive idea. And it doesn't matter where it occurs in the chapter or whatever, it's going to be closely related. If you're using the same embedding model to do the semantic chunking that you are to do retrieval later, you're also definitely going to chunk things in a way that that embedding model thinks they are related. So when you introduce a new query and it thinks it's related, it's likely that there's going to be consistency between that relationship, which is awesome. So it's an awesome idea. It is heckin' expensive though, right? Like it is very costly because you have to do a ton of computation across all of these chunks, and it does mean that you're gonna spend a little bit more, especially compute time. Luckily, not like GPU compute right now, though I'm sure it'll get accelerated. But it's gonna take longer, and so scaling it up into the millions of documents is gonna be more expensive than other approaches.
Speaking of cost versus performance, we got a long context window question here. What do you think of the recent many-shot approach? Large context windows allow hundreds to thousands of in-context examples, which seems to work even better. Let me rephrase this in, I think, the colloquial term. Do we even need RAG? Like, why do we even need it, Wiz?
I mean, no. I mean, we don't need RAG technically if we have infinite context like models, but practically we absolutely do. Like the amount of time it's going to take to parse through all that information, especially if it's on every single prompt, right? One of the motivations for fine-tuning is to ingest the information in the context window into the model so you don't have to have it in the prompt every time, right? At this point, like it would be easier and probably more cost effective depending on your situation, your setup, and what kinds of models you're moving using. So don't take that as a law, right? But it's probably going to be more efficient or cost effective to just train some adapters that you use to augment the behavior of the model with those examples, as opposed to needing to resend them every single time. And you can talk about things, well, we can just cache the examples, and so it's not actually going to cost us a lot in the long run. Yeah, that's true, and there's a lot of ways we can think about that problem. Secondly, what I'd say is large context is good, but there are industries and enterprises and organizations that have petabyte scale or even more data. And even if we have infinite context window, even if we have attention, linear attention, right? It's still going to take a long time to chew through that information. And again, you can solve it through caching, but at this point, we're just building a database in our GPU, which is very expensive. So
yeah. Okay, all right. I like that. I think I'm learning a little bit more here. Yeah, this real trade-off between RAG versus long context and RAG versus RAG as a competitor to long context window prompt caching, I think is sort of an interesting discussion we can continue. In terms of alternatives to both of these things, are there any? Is there something else I should know about? Am I covered here with these two patterns?
I mean, loosely, I think we could say like prompt engineering would be like kind of a third part of this equation, but it's not a meaningful inclusion, I think, because we kind of lump that into RAG-like process or just interacting with the model in general. But I do think that fine-tuning up to and including, whatever we're going to call lots of few shot examples, many shot, right? Up to including those methods.
Oh, nice little dovetail into the many shot in context learning question. Isn't that kind of fine tuning? Is that what you're saying here? It's kind of, I mean, I know you hate it when I use words like kind of fine tuning. What would you say is the difference between many shot in context versus fine tuning?
Yeah, I mean, so fundamentally, the difference is that it's happening in the context window, and we know that the model interacts with the context window in a different way than it does when we update its weights, especially when it comes to the fact that that's considered very recent information. So the model is going to be biased towards that particular style very heavily, which is why things like few shot learning and of course any extension to few shot learning work so well, right? Because the model has just seen this right now. It's primed for exactly this use case. But I would say like it is. I would not say it's close to fine tuning because I can't bring myself to say it. But what I will say is
I would, by the way. I think it's pretty close. Yeah, it's close-ish. Yeah,
it's closer than few shot for sure. And I think that it's useful to think of it. I think the second part of the question is absolutely true. You would probably fine tune the model in those exact examples. And so that is a useful way to think about it, right? That if we just keep doing this thing, but we also let the model update its weights, that is what fine tuning is. That's all it is, in fact. So that second part slaps with truth.
Yeah. All right. A couple. We're gonna do some rapid fire. We're at time here, but we just want to hit some rapid fire ones here for everybody. So quick answers here. Can I use the same data set format to fine tune various LLM models, or should each model have a special data set format?
Almost all models right now have special data set formats, if what you mean is the prompt format.
Got it. How much VRAM would be required to run Llama 8B without quantizing?
Oh yeah, so I did bring this up, Sarah. If you can quickly share my screen, the idea is so you can run it on less than 8 gigabytes of GPU RAM.
Oh, nice.
I brought it up. I ran the whole thing just to show you. Yes, less than 8.
8 billion, 8 gigs? Huh. Makes a lot of sense. Makes a lot of sense. Okay. Suppose you have to summarize a task where you only look at one document at a time. Would RAG still be the starting point? I don't know if I understand that question.
I think, sure. I don't know that I understand the question either very clearly, but yeah. I mean, you can use RAG for summarization if you wanted to, one doc at a time. You'd probably want to just use the summarization model, though.
Yeah. Or you can just prompt it to write a summary. There's lots of ways to combine these 3 patterns that we talked about today. And finally, I just want to sort of hit this Gango Babu in chat. Ganga, is it ethical to fine-tune sensitive financial information? I think the point here is we got to be using the right type of models. Isn't that right, Wiz? And then it's fine.
Yes, I think we want to use models that are in domain as much as possible. Yeah.
In domain, and keep it open source. If it's sensitive, don't let other people access it, and stay away from the APIs like closed source, OpenAI.
It is only ethical to fine-tune sensitive information if you are not sharing the model with people that could not or should not have access to that sensitive information. You will leak PII. You will. It's a certainty. It's not like a gamble. You will leak PII if you've trained on it, and so you should not share it unless you have the express consent of whatever parties gave you the data.
Yeah. And like, it should be your data, and you should be like following the rules with it. Yeah, for sure. So if it's your business, if it's somebody else's business, Ganga, stay away, my friend. All right, that's a wrap. We're gonna call Dimitri back up to close us out. Thanks so much to Data Phoenix for having us.
Yes, thank you, Greg. Thank you, Wiz, that you will be today with us and share your knowledge and prepare so interesting presentation. Thank you for all who watch this webinar. I will be happy to see you all on the next webinar. Don't forget to subscribe to our YouTube channel, join to our Slack channel, and visit our website where we write daily last news, last update from AI industry.
Thanks, everybody.
Thank you.
Thanks, Dimitri.